Hello everyone, welcome back to 3E, so finance and application using the arithmetic, arithmetic sequence and recurrence relations. So today we're going to talk about a simple interest. So we're using recurrence relation to model the simple interest first. So hopefully you still remember what's the recurrence relation from the previous videos. And now we talk about simple interest usually determining the multiplying the annual interest rate. So which is we're using R%. So by original amount borrowed the investor calling the principal. So which is like you invest how much that you have to. We call the principal P. And so each year of the loan for each year of the loan, so we don't know how much you're gonna loan for the each year, so we need to know. And another one will be we can say the value from n plus 1 year, so the value after n years plus the interest the previous year. So you always plus one. Uh, so we know the initial one is your principal. And next year will be n plus 1 for first year interest and plus d. This one is your interest. So after the first year, second year, third year, and so on. Let's try with questions first. So first thing first, you invest the $3,500 pay the interest and then rates is 4.2%. So first thing first, if you want to write something with your R, it's 4.2%. I normally write down 0.042 as a decimal. And the annually for form simple interest, find the amount of interest paid each year. So first thing first, we need to know the initial value. So which is we say V0 is $3,500. And capital D means we're gonna calculate will be so pretty much 4.2 divided by 100 and multiplied by 3,500. And we use CAS calculator to calculate this. So 4.2 divided by 100. And then you multiply by $3,500, which is of $147. Perfect. And then that's your day. For each year to investigate will be so each year the investment earns for $147 in simple interest. Perfect. Example 2. So now you have your following recurrence relation, and we're gonna try to say what they're asking first. So first thing first, we need to know what's your initial like the investment, so which is $2,000, and but each year we're gonna plus 150, which is this is your interest per each year. Uh, so now what we do is we got this recurrence relation. So what we do is we're gonna try to follow the rule to talk about it. So now what we do is use the recurrence relation to find the value of the investment after 1, 2, and 3 years. Okay, that's all right. I'm gonna make some tables later and I'll show you. So initial value is $2,000, and each year you're adding on is using the Vn plus 150. So that's your principal and plus your interest. So V1 will be equal to V0 plus 150. So which is $2,150. This is after 1 year. And V2 equal to V1 plus 150. That equal to 2150 plus 150. That's equal to 2300 after 2 years. And V3, which is the 3 years plus 150, that equal to 2300 plus 150, that equal to $2450 after 3 years. Yeah. So, or you can use the CAS to calculate as well. So I will show you how we're doing this. And so we just keep adding on. So we just plus 150, plus 150, plus 150, and so on. And we say question B, when they can actually reaching to $2,750 after how many years? So we just keep adding now. So we have 3 years is 2450. So V4 equal to V3 plus 150. That equal to two. That equal to 2600 after 4 years. So we just keep going. So V5 equal to V4 plus 150. That equal to $2,750 after 5 years. So after 5 years, we're reaching to our goal, which is $2,750. Hopefully that makes sense. So this question, I want you guys to pause it and try to do with CAS calculator, and then we can talk about it during the class. So that will be help you guys to understand a little bit more. So let's try to do some another knowledge about the rules for terms of sequence. The linear growth decade for the recurrence rate. So now what we do is, uh, um, so now what we do is we have answer terms of sequence generally and the recurrence relation. So the initial value will be the starting the point. Uh, so we start from when n plus 1 when n plus d. So this is your initial reference, the recurrence relation. So what we do is we could start some question like that. And they given you to how many terms we have and to multiply by your interest growth. Okay. Um, so put this one to your belt reference, and they're gonna help you to understand a little bit more. So now what we do is we're gonna using some examples. Let's try to have a look at this one. First question: how much invested for each year? Using that number straight away per year. Um, the question B, Use the rule find the value of the investment after 15 years. So now what we do is we're using our recurrence. So we n equal to v0 plus n times d. So it's 15 years. So we know n equal to 15. And d equal to 260. So v0 is 4,000, so which is 4,000. So v15 equal to 5,000 plus 15 times 260. Use the CAS calculator and calculate it. 4,000 plus 15, and that will be around $7,900. So this is a question B. And then they know when they're gonna hit the 10K. So what we know is the VN equal to 10K, but we don't know how many years we know. So 10,000 equal to 4,000 plus n times 260. So we're gonna using solve function. We're using CAS calculator to do the solve function. So 260 n equal to 6,000. So n equal to 6,000 divided by 260. And that equal to approximately 23.07 years. That means we have to hit the integer number, the whole number. We have to 24 years to reach 10,000. Hopefully that makes sense. And then this is I want to say about int 3e with financial simple interest. And in next chapter, we're going to talk about the geometric sequence. See you guys next time.